Okay guys, so in this short video we're going to be talking about how to perform reflections. So reflections, if you remember, it's basically when you are flipping an image, kind of like when you look at yourself in the mirror, you're actually looking at a flipped image of yourself. So reflection is basically when you're performing the flipping of an image over either a two-dimensional surface or a line, for example. So that is a reflection. So in this case, we're going to be forming the reflections of these shapes, and then we'll move on to more complicated or in-depth problems. So we got to perform the reflection over the y-axis. You have to know kind of where that is. So I'm going to use my highlighter here and then highlight the y-axis. So the thing about reflection, reflections in general, is that the distance stays the same from the line of reflection to the original point and to the new point, to the reflected point in the opposite side of the line. So what that means is that if I have 3 points A, B, C here, and I want to perform a reflection over the y-axis, I have to go the same distance that B is away from the line, but on the opposite side. So my new point will actually be here, and I would call this B prime. So if this is 1 unit to the left of the line, it's going to be 1 unit to the right of the line for it to be reflected. Same thing with A. If A is 1, 2, 3 spaces to the left of the line, I have to go 1, 2, 3 spaces to the right. And this will be my brand new A. If I have C as 1, 2, 3 spaces to the left, so that'll be 1, 2, 3 spaces to the right. And that'll be my C prime. So if I connect A prime to B prime, and then B prime to C prime, and then C prime to A prime, it looks like my original triangle here got flipped, and it's looking at itself in the mirror over this line. So it's like its mirror image. Okay, so all we're doing is counting spaces, counting squares, and keeping the distance the same over the line. So let's do another one real quick over the x-axis. So x-axis would actually be this line right here. So we're counting spaces, how many spaces away from the line we are. And we're doing the same thing on the opposite side of the line. Now be very careful here. It's on the opposite side of the line, right? I notice I didn't say above or below because it's the opposite. So notice A here is 1 unit above the line. If I want to reflect it, I have to go 1 unit below the line on the other side. So this will be my new point, A prime. If C is 1, 2, 3 spaces below the line, I got to go 1, 2, 3 spaces above the line. And this will be my C prime. If B is 1, 2, 3, 4 spaces below the line, I got to go 1, 2, 3, 4 spaces above the line. And this will be my B prime. Now, it doesn't look like anything yet, but if you connect A prime to B prime with a straight line, and then B prime to C prime, and then C prime to A prime, it looks like this image got reflected over that yellow line, or the x-axis that I highlighted there. Or another way to say that is it looks like the image got flipped, right? So think of like you're flipping a pancake and you're turning it over that line. That's what that would look like. Okay. The last example that I have here, well, at least for this section, we got to flip it over the line x equals 1. Now, you have to know where that is at and be very careful. X equals 1 is actually not going to be a horizontal line. It's going to be a vertical line. So it's going to be going through the x-axis at the number 1, so positive 1. So it actually will be a vertical line that goes up and down through the x-axis at positive 1. So make sure you know how to graph that, otherwise you would get the wrong answer. So now that you know where that's at, the rest is the same. You just basically have to count the number of spaces from every single point to the line. So B would be 2 spaces away. I'm going to do that on the opposite side, 2 spaces away to the right. A is 1, 2, 3 spaces away, 1, 2, 3 to the right. C is 1, 2 spaces away, 2 to the right. And then D is 1, 2, 3, 1, 2, 3. So keep the distance the same on the opposite side of the line of reflection. So if you connect the dots, you should see that it looks like the image is flipped or mirrored over this line right here. But notice that the distance is no longer to the y-axis, it's actually to this line right here. They could ask you to perform a reflection over any line that they want to, so you know, don't feel like you have to be constrained with the x or the y-axis. Now, lastly, the only other thing they could tell you is if they actually give you the reflection, so they give you the original and they give you the new, image after reflection. So you have to give the rules. So what happened here? What did you What did you flip it over? For that, you need to figure out, okay, well, I know that it's a reflection because the images look flipped. I know that much, right? The only thing is, I don't know where the line of reflection is, so let's try to figure that out. So if you remember me telling you that the distance stays the same from the line of reflection, then all you have to do now is take the original point and the new point and find which way is halfway between those two, and that'll be your line of reflection. So if I count squares or spaces, I have 1, 2, 3, 4 spaces here from here to there, right? The original and the new A. So halfway between those, I would have 2. So this would be halfway. Now, if that's my halfway point, then my line of reflection has to be this one going horizontally this way, right? So we basically just have to say, what is the equation of the line? If it got flipped over this. So notice that the distance stays the same. So A is 2 spaces away, A prime is 2 spaces away, B prime is 4, B is 4 on the bottom, so we're good. So this will be a reflection over the line. How would I write this? Again, be careful. It doesn't cross the x-axis, it crosses the y-axis. It's going to be y equals, because it crosses the y-axis, and that'll be positive 1. So it's going to be a reflection over the line y equals 1 because it crosses the y-axis at positive 1. So this is my line of reflection here. Okay, move on to the next one. What the heck would my line of reflection be here? So if we look at it, it looks kind of like it flipped over itself, which is fine. I'm going to go ahead and choose A and A prime, just so we can see where the halfway is. So to get from A to A prime, it is 1, 2, 3, 4 spaces, so halfway would be 1, 2. So my line of reflection in this case happens to be this line, which is also known as the y-axis. So if you want to give it, an equation, that's fine. This is known as two different things, right? So we can say that this is a reflection over the y-axis. You can leave it at that. Or the y-axis is also known as x equals 0. So if you think about it, it crosses the x-axis at 0. That's also known as the y-axis. Okay, last one. So we have to figure out what is the line of reflection between these two, the original and the new image. So if we count B to B prime, that is 1, 2, 3, 4 squares. So again, if we go halfway between 4 units, it's 1, 2. That means that the line of reflection would actually be here. It's going to be a vertical line, which means that it's going to be crossing the x-axis. And then the question is, where does it cross the x-axis? Well, it crosses the x-axis. This is the origin, 0, 0. This is positive 1. So it crosses the x-axis at 1. So it'll be a reflection over x equals 1. Okay, so hopefully this video was helpful. Good luck on your work. If you have any questions, feel free to pause, rewind, or talk to me in class. Have a good one. See you guys in the next one.